Okay, yes, hello and happy Friday. And I hope your first 2 weeks have gone well enough. I know things are still kind of rough, but I hope things are going okay. Um, and I hope you have a bit of time to just kind of relax. We have a day off. Monday is Dr. Martin Luther King Day, so no school there, and so hopefully it's just a little bit of a break that, that I hope you can enjoy. All right, let's go ahead and take a look at today's lecture. We are going to be talking about environments and scoping rules, and all of my content is based very much in part on material published and written by Hadley Wickham. Pretty much all of the illustrations that you will see in today's lecture I've taken directly from his textbook. Okay, so I think we have a bit of a notion on this concept of binding and scoping. And that's basically the idea that, when you run a function and it, uses values, the values it uses are the values that are defined inside the function, and the values inside that function are separate from the values inside, say, the global environment. Okay. So just kind of overall, we've got some objects created, and you create objects, you create functions, and they're all kind of stored, in the workspace, which we call the global environment. Whereas when you execute a function, when you do that, it creates a local environment. And inside that local environment, we can have objects, and those objects inside the local environment are only accessible within that environment and within that function. And those objects that we create inside a function don't appear in the global environment. They don't even interact with them. And if you have a local environment, objects in the local environment, those names take precedence over objects in the global environment, okay? Or another way to say is that the object in the global environment, its name is masked by the object in the local environment with the same, that has the same name, okay? And so within the function, if you refer to value x and you have an x inside your local environment, it's going to use that value, not the one that exists in the global environment. And what we're going to do today is kind of formalize a lot of these concepts and ideas. All right, now the way R works as far as naming variables and stuff is it uses pointers, okay? And so when you do something like this, okay, when you say x gets the value, we're going to assign this vector 1, 2, 3 to the name x, we often think of creating some object x that contains these numbers 1, 2, 3. But technically what we're doing is we're just binding the name x. Excuse me. We're binding the name x to this value 1, 2, 3, and this value, this vector 1, 2, 3 exists in a location in memory, okay? So you do this, inside your computer's memory, we create this vector, values 1, 2, 3, and we give it an address, and then that name x points to that location in memory, okay? And that's what's going on, okay? And so when you do something like this, okay, here I say 1, 2, 3 gets assigned to x. We're going to assign x to y, and then we're going to create 1, 2, 3 to z. What's the difference between y and z? Okay, they both have the values 1, 2, 3, but they're actually two different objects that happen to have the same value. So again, variables in R are references to memory locations of the objects. So the names x and y are pointing to the same object that have the value 1, 2, 3. So x and y are both pointing to the same object 1, 2, 3. And z points to another object. There's another object in memory that happens to contain the values 1, 2, 3, but it's pointing to a different thing, right? All of these memory issues and allocation and all of that and the cleanup is all handled by R automatically. You don't have to worry about it, okay? I don't know if anyone's taken any computer science courses, but if you're working in another language like C or C++, you have to worry about, memory allocation and, cleaning up these objects after yourselves. Otherwise, you end up with these memory leak problems and stuff like that. Okay. You think, well, how can this be when I modify something, things behave like copies and stuff. And so, what happens here? Okay, so here X gets the value 1, 2, 3. We're going to take the name Y and point it to the same object as X. And here we're going to say, change the third value in Y to the number 4. Okay, and I use double square brackets, but I could use single square brackets. Okay, and when I say, okay, well, what happened to X? X still remains 1, 2, 3. And, I said, well, I thought Y and X were pointing to the same name. Well, they were. At this point, they were pointing to the same object with the value 1, 2, 3. But this operation where I'm modifying the third value to 4, when R sees this, it creates a copy. It says, you know what? Oh, you're changing this. Even though Y is pointing to this object, what we're going to do is we're going to create a copy of it. Okay. And so we're going to create a copy, and the copy is going to contain 1, 2, and 4. And the name X points to the original object, which has 1, 2, 3. And that's how R handles this kind of stuff. We've got copy on modify. Again, probably something you don't have to worry about too much on a day-to-day basis. Okay, assignment is this act of binding a name to a value. And scoping, on the other hand, is finding the value associated with a name. Okay, so the scope of a variable is the region of your code where this variable is defined. Okay, and so I think this is fairly, I think we have an understanding of how this works. I define the name Y, and it is bound to the value 1 in the global environment. And I'm creating a function G in the global environment. G is a function of X. And inside the function G, we bind the name Y to the value 2, and G is going to return the value of X plus Y. And so if I call G with the value 3 here, so, X gets the value 3, what is it going to return? Is it going to return 4, or is it going to return 5 if I call G on 3? Okay, well, I was hoping for more participation in the chat here, but in this case, yes, thank you guys. In this case, it will return the value 5 because, X gets the value 3, and it's going to add the value Y, and inside Y, and what is the value of Y? Inside the function G, Y gets the value 2. So it's going to return 5. Okay, so that's this name Y inside the local environment masks the name Y, which is defined in the global environment. Okay, so that works the way we expect. Now, this is not recommended, but this is often something that we rely on. Okay, and so here I've defined another function F. F exists in the global environment, and inside F, I don't define Y. I ask for Y. It's a function of X, and we are going to say, I want to return the value X plus Y. Okay, and so if I call F on 3, X gets the value 3 when it would call F, but it can't find Y inside. It's not low. There's no value for Y inside the function F. And so what will it do? It searches the higher scope. Okay, F is defined in the global environment. It searches the global environment, and it's going to find the value 1. Okay, and so F on 3 is going to return 4. Okay, and this rule, this is known as lexical scoping. This R scoping rule. If R can't find a variable in kind of the function's body, it's going to search the higher scope, and it's going to keep searching higher scopes until it finds that value. So when we call F of 3, it returns the value 4. All right, I don't think there's any surprises here, right? It seems okay. And so again, it's important to remember that variables defined within a scope only exist in that scope and only for the duration of that scope. If we have, if a variable exists with the same name outside of the scope, those are separate, they don't interact, and they're not overwritten. And when a function runs, it kind of creates its own separate environment. And the only way it communicates to the outside world, higher scopes and stuff, are via the arguments going in and the return object going out, right? So for example, and this is a terrible idea, but if you run the code rm list equals ls, which is how we wipe out everything in the environment, if you run that inside a function, you would only delete the objects that have been defined inside that function, okay? And there's an exception. It's called the superassignment operator, which is this double arrow, all right? And what that will do is it'll search the higher scope and the global environment. And I hesitate to even teach you. I've got some slides in today's lecture covering superassignment, but I hesitate to even teach it to you just because I don't want you to use this operator at all in your code. Okay, it's bad practice to use it. So I hesitate to even show it to you. But sometimes you'll read someone else's code, and they didn't have me as a teacher, and they decided to use superassignment. And you see this operator, and it's hard because if you see an operator that you don't recognize, it's often hard to try to search for help, right? Because you're like trying to type in these symbols into Google, but Google doesn't know how to interpret this, and you don't even know what to call this thing, right? So this thing is called the superassignment operator. So yeah, with great power comes great responsibility. Yeah. Oh man, that was heartbreaking. But don't use the super assignment. This is my recommendation. Okay, we got XYZ is 1, 1, and 1, and in the global environment. And let's try this function. Okay, and so here f is a function defined inside the global environment. Inside of f, we bind the value 2 to y. And inside of f, we define another function, g, okay? And then, and f says return the value g. Okay, so when we say return the value g, we got to call execute g. And inside of g, we bind the value 3 to z. And g returns x plus y plus z, x plus y plus z. Okay, so if we call f, what is it going to return? Is it going to return 3 or is it going to return 6?
6.
It returns 6. Okay, so when we call f, it returns 6 indeed. Okay, because when we say return g, we execute g, and it searches for x. It doesn't find x here. It doesn't find x here. Finds x in the global environment. X gets 1. And we ask for y. It searches for y. There's no y inside of g, but it finds y is 2 inside of f, so it's going to take y is 2. And it asks for z, and it finds z is 3 inside here. And so we get 1 plus 2 plus 3, and we get 6. After running f, what are the values of x, y, and z in the global environment? Do these get changed or do they remain? They remain, okay? They remain 1, 1, 1. Okay, so f will return 6. It uses 1, 2, and 3, but the values x, y, and z in the global environment remain 1, 1, and 1. Okay. Did I give you your view quiz answer yet? No. Okay. Your first view quiz answer today is B. B as in bear. B as in bear is your first view quiz answer. Let's talk about environments. Okay. So environments is the data structure that powers scoping. Okay. And you can actually create environments. All right. So now normally we interact with environments by just kind of running functions, and environments get created. But you can kind of create your own environment. You can call new.environment, new.env parentheses, and we're going to create a new environment called E. And basically the job in an environment is to bind names to values. Okay. All of the value, you can't have a value in an environment that doesn't have a name. Okay, the environment will just contain names, and then and those names are bound to values. Okay, and you can think of an environment as a bag of names. Okay, so each name pointing to an object is a name pointing to an object in memory. So here we have the name A, and it's pointing to the value false. B is pointing to a character A. C is pointing to the name C is bound to the value 2.3, and the name D is bound to the vector 1, 2, 3. Okay. Environments themselves are objects. Environments themselves are objects. And the syntax to work with environment is similar to working with a list. Okay, so you can use the double bracket operator. You can use the $ operator. And so you can say $C. Okay, we'll ask, what is the value associated with the name C? We get 2.3. E double square bracket D. What's the value associated with D? And we get 1, 2, 3. You can't give it a position. Okay, so you can think of an environment kind of like a bag or a backpack, right? If I handed you a backpack, or you hand your friend a backpack, and you tell your friend, hey, I want the third object in my backpack. I want object 3, number 3 in there. That's like a nonsense thing to say, right? Because the objects inside your backpack are not ordered. There's no first object, second object, or third object, right? It's not a list where things are in order. It's just kind of a scattering. So it doesn't make sense to say, hey, I want the first item or the fourth item in a bag. Okay, you have to call things by name, right? You say, give me the pencil, give me the calculator. But you can't say, give me object 5 from my bag. It's not going to work. Okay, you can get all of the names that exist inside an environment by calling ls. Now, frequently we just call ls inside the global environment, and it will list off all of the object names that exist in your global environment. But you can specify, I want to look at environment E, or whatever environment you're talking about, and it will say, oh, the names that exist in there are A, B, C, and D. And then you can also ask for the structure of the objects inside the environment. You can ask for more details, and it will say, oh, A is this, the value false, it's a logical vector, and B is type character and things like that, and it gives you more details on this. Unlike lists, you cannot use single square bracket notation, okay? And if you take an object name and you assign null to it, it doesn't remove it, right? So if you did this to a list and you say, this item, the third item in the list, or object D in the list is null, it's going to kill that thing. It's going to delete that, wipe that out. But inside an environment, it doesn't remove it. Okay, it takes object D, now has the value null associated with it. Okay, it's now D is now pointing to the null object. If you wanted to remove an item from an environment, you call RM. RM will remove it. Okay, so you call RM to remove things from the global environment, or if you want to specifically say remove the object with the name D inside this environment, environment E, you can specify that. Okay, and after you do that and you say, well, what are all the objects in environment E? Now the object with name D has been removed. Okay, every environment that you work with has a parent environment. Okay, and so in these diagrams, from Hadley Wickham, all of these, the parent is indicated by this kind of blue circle. Okay, and the parent environment, this concept is used to implement lexical scoping, and that is to say, if we can't find the name in a particular environment, if we start here and we're looking for the name E, we can't find the name E here, we're going to search the higher environment until we find it here. Okay, and basically every environment has a parent environment and in R, and they keep going until you reach the empty environment. Okay, there's only one environment in R that doesn't have a parent, and that's going to be the empty environment. So kind of the important environments that we have to kind of know are the global environment. This is going to be your workspace. This is where you normally work. The parent of the global environment is the last package that you have attached with the command library or require when you load libraries, when you call that, whichever one you did most recently, that's going to be your global environment's parent. The base environment is the environment of the base package. The base package contains kind of your base operators like C. We use that to create vectors and list, and kind of your very basic things that you need to do inside R. I think mean is a base environment function, okay? And then you have the parent of the base environment is the empty environment. The empty environment is the ultimate ancestor of all environments. It's the only environment that has no parent, okay? And then if you call environment, that's going to be your current environment. That's going to be your current environment. When you call the function search, what that's going to do is it's going to list all of the parents of your global environment. This is known as your search path. Objects in these environments can be found, okay? And so, so this is kind of how it goes. So if you type in search right now, it'll probably have a list of packages that are similar. Here, because I've knit it, it loads a package called knitter, but there's other packages like the stats package, the graphics package, graphic devices package, and it keeps going until you return get to the base package, okay? And this is basically how it finds functions. So, you know, for example, when you call, you say, I want to find the mean of a vector, okay? You don't have a function, you didn't write a function called mean inside your global environment, okay? You don't write a function called mean in your global environment. And so what it does is it's going to say, oh, let's look for a function called mean, and it finds the function mean inside the base package, and it uses that, okay? You know, perhaps you say, I want to create a linear model, okay? I want to create a linear model. Again, you haven't created a function called LM, but when you do that, it's going to start a global environment. It's going to keep searching higher packages, and it's going to find the function for creating a linear model inside the stats package, and it does it there. Okay, and so kind of the search path is a linear thing. Okay, so each package has just one parent. Okay, and it's going to be, you know, all of these packages that are loaded until you get to the base package, base environment, and the parent of the base environment is the empty environment. And anytime you call a new package using library, okay, anytime you call a new package using library, that package is going to get inserted between the global environment and the most, you know, the second most recent package that we called, okay? And so, you know, every time you load packages, the parent of your global environment changes. And so this order of packages that get loaded could vary from one person to another. So if one person loads their packages in one order and somebody else loads their packages in another order, this order of packages is going to be different from user to user. Okay. When we talk about a function and execute a function and things like that, okay, there are a lot of environments are going to be kind of created and used. And this is kind of our probably the most common way we interact with environments. We don't generally create environments using that function new environment. Our interaction with environments is usually through functions, okay? And so functions have 4 environments associated with it: an enclosing environment, a binding environment, an execution environment, and a calling environment, right? The enclosing environment is the environment where the function is created, where the kind of the code for that function, where does that code exist? What environment is that in? That's the enclosing environment. Every function has only one and only one enclosing environment, okay? The other environments, the binding, execution, and calling environment, might have 0, 1, or many environments associated with that thing, okay? The binding environment is where the name for that function exists, okay? So when you refer to a function, where does that name exist? That's the binding environment. A lot of times it's the same as the enclosing environment, okay? When you call the function and it is running, that creates the execution environment. The execution environment is a temporary environment that stores all of the variables that are used during the execution of the function, and it will disappear once the function finishes. And whenever an execution environment is called or created, so whenever a function is called and it creates an execution environment, the execution environment is also associated with a calling environment, which tells you where the function was called. Okay, let's, let me say a little bit more about this enclosing and binding environments stuff. Okay, when a function is created, it gains a reference for where it was made, and that's going to be the enclosing environment. That's the function that gets used for the scoping rules. But when you name a function, all right, which has often happened at the same time where you create the function, but wherever you name it, where that name exists, that's the binding environment. And so most of the times, your enclosing environment and your binding environment is the same. Most of the time, you're doing this inside the global environment. So, you know, most frequently, your function, your enclosing environment, binding environment, it's going to be the global environment. So here, I'm going to define one. I'm going to define the name y and bind the value 1 to it inside the global environment. So inside the global environment, we're going to bind the name y to the value 1. Inside the global environment, I'm going to bind the name f to a function, okay? So f is going to be the binding, the global environment is also the binding environment. But this code here, the code of the function, the code of this function, where is this code created, okay? Well, f is created also inside the global environment. So in this case, the global environment is also the enclosing environment. So when I say, what is the environment where, you know, f is created, or, you know, where that code was created, that's also going to be the global environment. So the enclosing environment is the global environment. And because the name also exists in the global environment, it's also the binding environment. And that's going to be the scenario for most cases here. Whenever you write some kind of function, most often your enclosing environment is the global and your binding environment is also the global environment. Okay. The distinction comes from when we often deal with packages. Okay. So, you know, when you look at the search path, the parent environment of a package varies based on, you know, what other packages have been loaded, right? And so does that mean, do we have to worry about packages behaving in different ways if people load their packages in different orders? Okay. And so, for example, if you ask R, okay, what is the standard deviation function? The definition of the standard deviation function, it says we're using the square root of the variance. Okay, we're using the square root of the variance, and it basically coerces x into. It says, you know, if x is a vector, or go ahead and just take the variance of x. Otherwise, coerce x into a double, and try to take the variance there. Okay. But basically, we're asking it to take the square root of the variance. Now, what if we defined a function variance? Okay, so right now I can take x 1 through 4, and I can ask what is the variance of x, and we get this, and what's the standard deviation of x, and we get basically the square root of the variance. Okay, but what if I decide to create a function called variance, right? So I'm going to say var is a function of x, and what this will return is it will return just the string hello. Okay, so if I say give me the variance of x, now it returns hello. Okay, and obviously that's not what I want. But if I call what's the standard deviation of x, I still get the right answer. Okay, so the variance of x is no longer returning 1.6667. Okay, and obviously if I call, you know, what's the square root of the variance of x, you know, I get an error, right? I can't take the square root of hello. But if I ask for the standard deviation of x, that works. The variance of x still gives me back hello. So how is this working? How is the standard deviation of x working here? Okay, even though the definition of the standard deviation says take the square root of the variance. Okay, well, to make sure that when we call the standard deviation function, and it's going to reference this variance function, to make sure that it's doing this correctly, R knows not to use the variance in the global environment, this var function that I've created in the global environment, but to use the variants associated with the package namespace. Okay, so you have the distinction between the enclosing and binding environment is important when we're dealing with packages. Okay, and you know, in your general day-to-day thing, when you're writing functions and stuff on your own, that the enclosing environment, binding environment is going to be the same. Okay, but when you're writing, if you're going to write a package, then you need to have a better understanding of how namespaces work. So to ensure that packages work the same way, regardless of what packages are attached and in what order, okay, packages require another environment, an internal environment called the namespace, okay, in which the package functions are defined. And every function in a package is associated with the package environment and the namespace environment. And by using namespaces, we can make sure, namespace stats, we can make sure that anytime we call the variance function, it's going to be the variance function that exists inside stats, inside the stats library, and not just some random old variance function that I've defined in the global environment here. Okay, so the package environment is the external interface to the package. This is the environment which the R user uses to find a function in the attached package. Okay, its parents determined by the search path. Okay. The double colon operator can be used to access a function directly from the package regardless of the search path. Okay, so for example, there is a function called mean inside base. There's also a function mean inside the package mosaic. And so when you call the mean in mosaic, you use mosaic double colon mean, and base double colon mean will refer to those packages specifically. All right. So right now, if I call variance on X, it returns hello. But if I want the real variance function, which is defined inside the stats, I can call stats variance X, and I get the actual value. Okay. So to distinguish and say, you know, I want the real variance thing, right? Because right now, var, the name var masks in a global environment masks this thing. Okay. Now I can remove it. Remove the name variance from there. Okay, so now it disappears. And so now there's nothing masking variance of X. And so the variance of X goes back to here. But when I had this silly function defined, when I had this function defined, the name variance would be found in the global environment, and it masked the regular stats variance name. Okay, so the double colon notation allows you to access objects that might be masked by other objects. Okay, so the namespace environment is the internal interface to the package, and that's how we can kind of control the functions. And so the namespace is how it finds the package that the functions that it wants, so, such as the variance function. Okay, when we execute code, we get the execution environment. Okay. Every time a function is called, a new environment is created that handles all of the execution of the code. The parent of the execution environment is the enclosing environment of the function. And once the function completes, this execution environment is just discarded. It's thrown away. So we're going to look at this very, very, very simple function. Okay. H is a function of X. Okay. Inside H, we assign the value 2 to A, the name A, and we're going to return the value X plus A. So I'm going to call H on 1. Okay, so how is this going to do? Okay, well, X takes the value 1, A gets the value 2. We're going to do X plus A, and we get 3. And we're going to, so this function will return the value 3. And then we're going to assign that value 3 to the name Y in the global environment. Okay, so when we first do this, H is defined in the global environment, okay? And we call H with 1. And so immediately, as soon as we call H, it creates an execution environment. And we are calling H with the value 1, okay? And so the value 1 immediately gets assigned to the name X, okay? So just in the, so the first view quiz answer, First view quiz answer was B. Okay, the first value, okay, or I'm sorry, this value X, okay, the name X is bound to the value 1. This happens as soon as you call it, right? As soon as you call a function, right, R recognizes H as a function, it creates an execution environment. And the very first thing it's going to do is it's going to say, the argument that came in is 1, we need to bind it to the name X. So X gets bound to the value 1 inside the execution environment. So this over here is the global environment. This is where the function H is defined, okay? And this is kind of how the function operates. The function needs a value X to operate. And so it creates an execution environment. This execution environment, inside the execution environment, we get the name value 1. I guess I haven't given you a second view quiz answer. Second view quiz answer will be A. A as an apple. A as an apple is your second view quiz answer. Second view quiz answer is A. A as an apple. A as an apple. Okay. So the name X gets the value 1. All right, now that we've called the function and we've kind of assigned the initial arguments that come in, then we can run the lines of code that we have, okay? So the next line of code says bind the name A to the value 2. So that happens inside the execution environment. The name A gets bound to the value 2. That happens inside the execution environment. Okay, the last line of code says return X plus A. Return X plus A. So X plus A we'll do, we're going to return the value 3. Okay, the function completes running, it returns the value 3, and that execution environment goes away. It's done. Okay, the execution environment goes away, and that value 3 now gets bound to the name Y in the global environment. Okay, and that's how it goes. Is there a name for the environment in light yellow? You mean this one? Or this is the code? The code, this is kind of the code for the, yeah, I guess the function itself. Okay, so this represents the function itself. So so this, Y points to an object with a value 3. H points to this thing. This thing points is a function, and the function has a parent environment. There's an arrow here to indicate that the enclosing environment of the function is the global environment. Okay, and this is to indicate, when you're searching for values here, it's going to search this parent environment. Whereas over here, this function, its parent environment, or its namespace is this. And so this is when it's searching for values, it's going to search for it in this namespace. So this represents, yeah, this is an object with a value 3. This is a function. It's an object which is a function, and it has an arrow to point that its enclosing environment is is this global environment here. Okay, so when you call a function, it creates an execution environment. The execution environment has technically 2 parent environments. It's got the enclosing environment where the function is created, and the calling environment for where the function is called. If you create a function in the global environment and call the function in the global environment, there's nothing to worry about. These 2 things are the same. Okay. Sometimes though, you call a function from inside another function, and in that case, the environments are different. Okay. R's normal scoping rules use the enclosing environment. So when it's looking for a value and it can't find it inside the function, it's going to search the enclosing environment, which is the function where it's created or defined, not the function where it's called. R also supports this thing called dynamic scoping, where you can say, I want you to search the environment that called it. Okay, and that's dynamic scoping, and that's uses a function called get. All right, so let's just try out some examples. I think this one will be fine. But we define X to be 0 in the global environment, Y to be 10 in the global environment. So these are values in the global environment. We have the function F, okay? Inside the function F, X gets the value 2 and Y gets the value 100. Inside the function F, we define another function H. Inside H, X gets the value 50, and we are going to return the value X plus Y. And inside H, when we execute H, the last thing it runs is it's gonna return the value of H. Okay, so when we call F, what will it return? We call F, we give X 2, Y 100, and we return the value H. Inside H, X gets 50, and we're gonna do X plus Y. It's gonna return X plus Y. Okay, so the question is X plus Y, X is 50 inside of H, so this X is going to get this value 50. Is it going to return 150 or is it going to return 60? Is it going to use Y from the global environment, or is it going to use Y from the environment F? So is it going to return 150 or 60? What do you guys think? You can enter it in the chat.
150.
150 indeed. Okay, so when we call it, F is going to return 150. It searches for X, it finds X, and it gets 50. When it searches for Y, it's not inside of H. It searches the enclosing environment where H is defined, which is inside of F, and it finds 100. So it returns 150. Okay, here's another example. Here I define G in the global environment. I define H in the global environment. Okay, first let's call H. Okay, what will H return? Inside H, X gets the value 3. And it's going to return X plus Y. It doesn't find Y. X gets the value 3. It doesn't find Y in the local environment. So it searches where? It searches up here and it finds 10. Okay, so H is going to return 13. Okay, when I call G, what will G return? G assigns X to 2, Y to 100, and it calls H. Okay, so we call H. Inside H, X gets the value 3, and then it's going to return X plus Y. Okay, inside G, Y is 100. In the global environment, Y is 10. When we call G, what is it going to return? Is it going to return 13 or 103?
13.
Okay, what do you guys think? So calling H returns 13. I think that's not a surprise, right? So when we call H from the global environment, we get back 13. When we call G, we also get back 13, okay? The reason for this is because H is defined inside the global environment. So even though I'm calling H from inside of G, okay, when we execute H, H is defined in the global environment. And when it can't find the value Y, it's going to search the global environment because H is defined inside the global environment. So even though we're calling H from inside of G, when it can't find it, it searches its own enclosing environment, which is the global environment. Okay, and so it's going to also return 13.
Can I ask a question?
Yeah, go ahead.
If you nested G into H, then it would use 100, right?
So
or H into G.
So yes, if it was like this, where H was defined inside of the other function, it would use you would use that value 100. Okay. Now we can have it like this, and we can do something known as dynamic scoping. So here, H is going to still be defined in the global environment, and we're going to call H from inside of G. Okay. However, when we ask to find Y, the value Y inside of H, rather than using the traditional scoping rules, which happens automatically, we're going to say, I want R to use, we use this thing called parent.frame, and this will say, don't use the normal enclosing environment, which would, because H is defined in the global environment, it would normally be 10. We say, use the environment from wherever this function is called. Use the calling environment, okay? So when we call H inside the global environment, X gets the value 3, and it's going to search for Y here. in the calling environment, which is the global environment, it's going to get y is 10, and it's going to return 13. But when we call G, inside G, X gets 2, Y gets 100, and we call H, okay? So we call H, X still gets the value 3, but this time when we say we need a value for Y, we're saying use the value from the environment from which it was called. And we're going to use Y as 100 here. We get Y as 100, and now we get X plus Y, we're going to get 103. So H returns 13, where now G returns 103. Okay, so this is known as dynamic scoping, and we can use the values from the environment from which it was called, rather than just the environment from which it is defined, which is the normal scoping rule. Normal scoping rule, because H is defined inside the global environment, it's going to always use this value up here. Okay, and that's what we have. Let me go ahead and give you your last view quiz answer. Last view quiz answer today is the letter C, C as in cat, C as in cat. Okay, these last few slides are on super assignment, and I hesitate to even go over this because I don't want you to use super assignment. Okay, so this is kind of just like, this thing exists, but please don't use this. I can't think of a regular reason. Somebody just signed off, but regular reason for you to use this this operator. Okay, but it does exist, and what it does is it's not going to search the local environment. It's going to search for the higher environment, and it's going to look for the name in the higher environment. And it will keep going until it reaches the global environment. And if it can't find it in the global environment, it'll create it in the global environment. But again, super assignment should be avoided. Now, I'm probably going to run out of time today, so I'll go over some of these slides. Also, in the modules, I have a supplement of R code. I have an R script where I have a bunch of these assignment operators. Please take the time to go over the examples in this supplement as well. Okay, so this is how the super assignment operator works. Okay, we're going to assign X, Y, and Z. I'll get the value 1 in the global environment. And inside this function F, we super assign the value 3 to Y. And what this will do is this will not assign the value 3 to Y in the local environment, but it will assign it to the global environment. Okay, in the global environment, it's going to change the value to 3. Okay, change the value up here, and it's going to return that to the user. Okay, so F will return when we call F, we get the value 3, and when we ask what is X, Y, and Z in the global environment, we see that Y in the global environment has changed. Okay, and you have to say, oh, that doesn't seem that bad. That doesn't seem that bad. Okay, but it's bad. Okay, now why is this bad? Why do I not like the super assignment operator? Okay, the reason why I don't like this is because normally when you change a value in the global environment, so something way back here, right? Here we're going to assign something to Y, and somewhere, as you're debugging code, you're trying to figure out, oh, how did I get Y to get the value 3? You can find it in your code. You're going to see this assignment. You're going to say, oh, this is where I'm changing the value Y, and this is where Y is getting the value 3. Okay, so there you can, as you're reading your code, you can look out for operators like this, where you can say, oh, here's an assignment, and we are changing the value of Y here. Whereas when this line of code gets executed, there's no indication that this is going to change the value of Y. The value of Y gets changed when this gets executed. It's not changed when we define the function. It gets changed when the function gets executed. And unless you've memorized all of the internal lines of your code, and you remember, oh, whenever I call F, I'm also changing the value of Y in the global environment. Unless you remember that, you're not going to, as you're troubleshooting, it's not going to be apparent and obvious that this is where the value of y is changing in the global environment. So this is why I don't like super assignment, because there's no indication that values in the global environment are changing when you execute functions that use super assignment. And that's where it gets hard. Okay, I got more of these examples of super assignment here, and I'm just going to go over these quickly. I already know I'm over time, but inside F, we're going to super assign 2 to Y. Inside G, we're going to super assign 3 to Z. And so here, it's going to change Y and Z to 2 and 3 in the global environment. It's going to search for those things. It's going to find them in the global environment. And we're going to get 1, 2, 3. And all of the, I have it all written in the comments here, and I hope they make sense, you know, as you review some of these slides later on. Okay, so F returns 6, and the values in the global environment are now 1, 2, 3. Okay, over here, again, it gets tricky because here I'm defining Y to be 2 inside the function F, but I'm also going to super assign the value 4 to Y in the global environment. And so when you execute that, it's going to use the value it finds here locally, and it's going to use 1, 2, and 3, but the values in the global environment will be changed to 1, 4, and 3. Okay. All right. So anyway, review these slides on your own time, please. And I do have a slide here that says avoid super assignment, and this is why it's confusing. But we'll go ahead and end here for today. Have a great weekend. Enjoy the Monday holiday, and we will see you guys back in class on Wednesday. So have a good rest of your day. Have a great weekend, and we'll see you guys on Wednesday.